industrial manufacturing, but also mining and ports. And they present unique challenges which you don't find in your typical enterprise environment. So first off, you have lots of environmental hazards. So extreme temperature variations, maybe lots of water, dust, fire maybe, chemical exposure. And the equipment in these networks needs to be able to withstand these challenges. A second key difference of industrial networks from enterprise networks is the life cycle of the equipment. So in the enterprise network, typically you put if it's an access point, a Wi-Fi access point, you might put it in there, and 3 to 5 years later, you might be refreshing that equipment. So maybe moving from Wi-Fi 5 to Wi-Fi 6, Wi-Fi 7 every 3 to 5 years. In industrial networks, they're in place typically, at least 10 years, often 15, maybe out to 25 years. So it's in place for a lot longer. So the life cycle of the equipment is considerably longer than what you find in the enterprise networks. That's another key difference. And a third key difference I think is really important to highlight is that the requirements of the machinery and the robotics in these environments they have very high performance requirements. And key to this is they are mission critical, so they cannot accept any downtime or disruption. So consistent reliability is really key for them. Obviously, if they go offline, it's very expensive for the facility and also very dangerous as well, potentially, because the cobot could go off and hit someone in the face. So it's obviously the consistent reliability is really key for these networks. So because of these requirements, historically, industrial networks have really prioritized wired over wireless. And this is actually still the case today. Last month, I was in the Industrial Manufacturing and Technology Trade Show in Chicago in the US, speaking with a lot of industrial manufacturers. And pretty much everyone reiterates that if possible, they're going to go with wired over wireless because they view it as offering the highest reliability. But that doesn't mean there isn't a place for wireless in industrial networking. And on the screen here, I've outlined some of the kind of key drivers of wireless adoption in industrial networks. And importantly, many of these are actually on the rise today. So first off, we've got increased automation. So automation, this has been driven by several different factors. So on the one hand, you've got the challenges of finding skilled labor. So we're all hearing about, challenges finding skilled labor in kind of manufacturing facilities. Automation can help overcome this challenge. Another key one as well is the high costs of the kind of labor. So as the cost of robotics come down or other kind of automation technologies come down, eventually it comes to a point where it's more cost effective to use automation than actual kind of physical labor. It's quite topical at this point. I think it was last week or maybe a week before there was some strikes in the east coast of the US. And the last I heard, I think they were settled, but they agreed to raise the salaries of the port workers. And at a later date, they're going to discuss, what their views on automation are and if they're going to bring it into the East Coast ports. Obviously, for the managers of these ports, this is something they want to avoid. Obviously, they don't want to have to keep discussing and renegotiating the costs of the salaries. And also, they don't want strikes, which are disrupting the operations. So this is one of the key drivers of automation, of course. That leads on to the second point, which is new applications. So if you need to use maybe AGVs or AMRs as a replacement for perhaps human labor, then of course you can't. It's not practical or feasible really to connect that with cables. Obviously, there'd be cables all running all over the place, and they might come unplugged and things like this. So really, you need to use wireless for these applications. And there's quite a few different points on the board, but I'll just summarize a couple before we move on. Basically, many of the kind of shortcomings of cable are also becoming increasingly more apparent as we increase the number of devices in these networks. So cables, they use up a lot of floor space. They have wear and tear during the use, which increases the chance of them going offline. And I think also as well, when you are refreshing or you're troubleshooting the network, wireless, of course, it offers some advantages because if it's wired, you've got to turn it offline, you've got to perhaps replace the cables, things like this. Wireless is, you don't need to do that because it's, you can do it all remotely. So when an industrial facility is looking for their wireless technology of choice, we've found that typically Wi-Fi is the technology which they are turning towards. To kind of reinforce this point, I've shared some recent survey results from a survey that ABI Research conducted of industrial manufacturers. We conducted the survey in the US Germany and Malaysia to give that kind of broad global coverage, but these are results from the US participants. We asked them of the deployment levels of different technologies. So you can see there's loads of, I don't know, digital twins, for example, 5G on there, machine vision. Of all the technologies, industrial Wi-Fi was at least from the responses we got, it was the most deployed technology. So I think this really highlights the confidence that industrial facilities have in Wi-Fi and also their familiarity with the technology. So when they are deploying Wi-Fi, what is the technology which they're deploying? This is one which may be a surprise potentially to some of the audience here today. The industrial market is really divergent from the enterprise market. It's vastly different. Often the key vendors are different players. They're deploying different technologies. And what really highlights this is that the majority of the shipments are still of Wi-Fi 4 today, so 802.11n. I think it was first introduced in 2008, so obviously it's considered a really legacy technology in the enterprise. But in industrial markets, this is still the predominant technology today. If you're looking at some of the key vendors in the market, like Siemens, for example, most of their shipments are still of Wi-Fi 4 in their ruggedized industrial wireless LAN access points. So this is still the majority of the market in the industrial space. So over 50%, just over 50% in 2023 were of Wi-Fi 4, and about a quarter for Wi-Fi 5 and Wi-Fi 6 respectively. So you might be wondering what happened to Wi-Fi 5. That's in orange on this graph here. Still significant numbers, but it never really took off in large scale in the industrial market. Several reasons for this. One is the life cycle of the equipment in the networks. If you installed Wi-Fi 4 clients in, say, 2010, and they're going to be in place for 15 years, which is maybe quite a short time frame in the industrial market, then obviously you're not going to replace your access points with Wi-Fi 5 in 2015, for example, because all the clients are going to be Wi-Fi 4. But more importantly, many of the features Wi-Fi 5 introduced are very beneficial for enterprise and residential networks, but they weren't so closely aligned with the needs of industrial networks. So that was why many vendors within the industrial wireless LAN market chose to bypass Wi-Fi 5 in their product portfolio and jump straight from Wi-Fi 4 to Wi-Fi 6. And many Wi-Fi 6 access points, ruggedized industrial wireless LAN access points, so that's quite a mouthful, they're coming online now. They're being introduced to the market. And we foresee that Wi-Fi 6 will see rapid adoption in the industrial market because it has many features which are closely aligned with the needs of industrial networks. Key amongst those is compatibility with the 6 GHz spectrum, which we'll talk a little bit more about in a moment. After Wi-Fi 6, which we foresee in shipment terms will become the predominant technology in 2026, we've then got kind of Wi-Fi 7 entering the market. And then further down the line, you've got Wi-Fi 8. A couple of words on those two technologies. Wi-Fi 7 is introducing loads of really beneficial features, including MLO, which you've probably heard a lot about in the show. And it's focusing on really delivering extremely high throughputs. This is really valuable for many enterprise applications and also residential applications, but it's not so closely aligned with the needs of the industrial networks. Because industrial networks are really focused on reliability. So Wi-Fi 7 will see some adoption, but of course the access point vendors want to get ROI on their investments into Wi-Fi 6, and there's a development timeline. It takes a little while to develop Wi-Fi 7 equipment as well. So what we foresee is Wi-Fi 7 will probably see a similar trajectory to Wi-Fi 5, and then Wi-Fi 8 will see really significant levels of adoption because of its focus on ultra-high reliability. If anyone wants to dig into these dynamics a little deeper, we can discuss it maybe later on because it's a little bit complicated to get across. But basically, in the industrial market, we're seeing like a skipping of the protocols. So Wi-Fi 4 to Wi-Fi 6, most likely then to Wi-Fi 8. I want to spend a minute or two discussing about 6 GHz. I mentioned that this is the most exciting innovation within wireless LAN for industrial environments. You can all imagine why, because of the additional capacity which it is offering and also helping to reduce interference and increase reliability. What we've done here now is shown our shipment projections for the industrial wireless LAN APs, but in terms of 6 GHz support. Last year, it was a very low number, obviously, just under 3%, but it's going to rise very rapidly over half, I think, in about 2027. And in 2030, it's going to be about close to 3/4 of the market. So rapidly going to adopt 6 GHz in industrial markets. The reasons why I think are pretty straightforward. But there's two things I want to note within 6 gigahertz in industrial. The first is that AFC systems are going to be really important in industrial networks. This is because automated frequency coordination systems, I'm sure most people in the room know, but they essentially scan the 6 gigahertz spectrum, check for incumbents first before they enable standard power 6 gigahertz transmissions. These are at 36 dBm, so they're a higher power than the very low power indoor requirements, which are set on standard on normal transmissions. AFC systems, they enable those higher power transmissions, but they also allow for external antennas, and these are really important in industrial markets. So without AFC systems, yes, you can't transmit at standard power, but you're also not allowed to have external antennas. So obviously this is really vital for industrial environments because you need the external antennas to fine-tune the transmissions. So AFC systems will be vital in industrial networks. And also, we're seeing that it's more of the space, not the cost, which is a key determinant of 6 gigahertz radio inclusion in industrial networks. So basically, in enterprise, they're very more cost sensitive. Yes, aesthetics is important and performance and everything, but cost is a real key driver, maybe probably the key determinant whether you're going to include a 6 gigahertz radio or not. In the industrial market, probably the outcome is really key. They need to make sure they get the best solution for their needs. But because they've probably got additional funds to pay for an additional radio, but the compactness of the equipment is really key because you've got to put it, maybe install it on an AGV or an end of a cobalt arm or something like this. So it's really the compactness which is key. So you're going to be seeing that it's the size, not the cost, which is the key determinant of the 6 gigahertz radio inclusion. Wrapping up, I wanted to quickly discuss some of the other kind of hardware and topology trends in industrial Wi-Fi networks. The first one we've already touched upon, compact designs. I think I will maybe highlight three, just in the interest of time. Enhanced security, this is really key. At the beginning, I mentioned about how industrial networks, they often prioritize wired over wireless. One of the key reasons is because they believe that wired networks offer a higher degree of security. Obviously, this means that Wi-Fi or industrial wireless LAN vendors, of course, need to bring in enhanced security to alleviate these concerns. Ease of implementation is another key one. When we've got the challenges finding skilled labor, and maybe system integrators who can install these networks, if we're using zero-touch provisioning and auto configurations, this can be a way to both accelerate the deployment and also to overcome any challenges you have perhaps in finding the skilled engineers to install the networks. Simplifying the installation is beneficial in many regards. So this is why it's one of the key focuses of innovation. And a final key one is sustainability. So this, I think, is globally, Europe obviously sees this as a major concern. It's one of the top kind of priorities, but it's also important in other regions as well, both for the meeting of ESG targets and then also for bringing down costs of running the network. Obviously, if you can reduce the energy consumption of the equipment in any way, that reduces the costs which are involved in powering the network, and that just improves the bottom line basically. So helps move the needle for the business. So that's why it's a key KPI for the development of the new industrial wireless LAN equipment. So thank you for kind of listening to the key takeaways there. We've probably got maybe a very short amount of time for any questions if anyone wanted to jump in. And yes, please shoot away.
So the economics don't really support, shall we say, a fully redundant AP. It just, I notice you have a redundant power supply put up here, but in the past, telecoms and whatnot have looked to fully redundant CPU stuff. It doesn't exist for this. Is that right?
I mean, I think what I'm referring to here is redundant power supply within this individual AP. But yeah, I get your point about having a redundant kind of second access point, right, for a fully redundant network, basically. I think that has been something which is redundant power supplies and a redundant kind of networking equipment. They have been around for many years already. But I think what we're seeing now is just an increase in the redundant power supply in individual access points. I think potentially the driver behind this is it's a way to kind of lower the costs while still increasing the kind of reliability of the equipment. I don't think it's going to replace the need for redundant equipment, but it's maybe just a trend which increases the reliability. So, yeah.
A question here. For this particular market, is there a separate set of suppliers? You know, could you talk about sort of suppliers, market shares in this market, access point, and then maybe also client side? You know, who are the players in this particular segment?
Yeah, I mean, I could probably do a whole presentation on that because it's a completely separate market from the enterprise market. So you've got key kind of vendors. I mentioned like Siemens, for example, is a really major vendor in the industrial wireless LAN access point market. You've got other, HMS Networks, for example, is another German vendor, which is actually a very large position in this market. Phoenix Contact, for example, is another major vendor. So these are vendors which you won't really see in the enterprise market, right? Moxa is another one. So there's a whole range of vendors out there. Unfortunately, I haven't got any kind of data with me today to kind of show you the kind of market shares of them, but you have got some enterprise players who are active in those markets. Some of the members of the WBA. And some of their strengths are of converging the industrial markets with the enterprise markets. So what the industry might call converging of IT and OT. So vendors who are active in both markets, they're really good at converging the two. But this also is sometimes not wanted from the industrial facility because it then again adds additional kind of concerns for them around security, right, and vulnerabilities into the network. But to summarize, yeah, it's a completely different set of vendors for the most part between the networks. Yeah, I'm not sure we've got time for more questions, or do we have to run on to the... Okay, right. So unfortunately, we've run out of time for this section, but we can catch up later on if we've got any more questions on the industrial market. I'd be happy to answer them.